The one goof I kept noticing at the very end was there was one probability distribution that maybe like 25% of you thought wasn't, but actually was. It was the second to last one, I think, where I asked you if something was a distribution. The first one that I asked you about wasn't. So then I think it was number 3, and then you'd skip number 4, because number 4 asked you for an average if there was one, and there wasn't one, because there wasn't a distribution, so you skipped it. The next one asked, is this a distribution? And for some reason, a bunch of you thought it wasn't because it isn't some of the one, but it does some of the one. And I'm guessing it was an Excel mistake. I can't tell. I can't tell because I didn't see what you did. You had the Excel sheet in front of you, and you were just telling me yes or no based on that. So I'm guessing that it was just an Excel mistake. It's totally fine if it is or isn't. And also, the problem with that was you also then didn't have the average in the next one because it was a distribution, so you had to have an average. So I think that was a 1-2 punch for a couple folks. And I apologize for that. I just don't know what the hell happened. Other than that, say that again. Wait, hang on a second. What's this question? Dawn, go. Natalie, go.
So we were talking about the second to last one.
Second to last one.
5 right. But like 6, I used the average command on Excel.
Natalie, this is good. This is good. Hold tight. Hold that thought, Natalie. Hold that thought. Natalie, this brings up a good point. She used the average command on Excel to take the average, and I'm assuming what you did was what did you average?
It was
The ones that were in the row. It's
in that row.
Which one though? The X's or the P of X's? Because you have to add, that's not, you're averaging data. Your data is actually the S. But now here's the deal. Here's the problem with Excel, and there's a footnote, you might not have seen it. There's a footnote on the project that says you can't just use the average command in Excel because it ignores the frequencies. You have to create, you have to actually do it.
There's a footnote on the first one that asks about the probability distribution, but the footnote is not on the second one.
Yeah, and I read
I went back and looked at it.
I read the first one, and then when I read that footnote, I was like, oh, then that must not be, because that sounds absolutely crazy.
Wait a minute, hang on a second, I'm confused now.
But no, that makes sense.
Hang on, I'm confused. I'll make sure I'm not confusing. Try to not be confused wherever I can, not be confusing.
Yeah, and I read the footnote for before, and when it didn't have an average, and I was like, oh, good, there should have been more, because that footnote's absolutely crazy. Yeah, so I was like, he must be.
So now, you're talking about this one right here.
Yeah.
Okay.
Yeah.
So the footnote's on number 4.
But you would have read that.
Right, but it's not on number 6.
And I thought it was crazy. But it applies to
I used my TI because I didn't want to do this.
This is the point where I go, you would have read it once, I'm not going to put it twice. I mean, I do that in class a lot. I repeat myself a lot in class, but I'm not going to do it here. So I see your point. So, and this is, and Natalie, you must not have seen it, it's totally fine. It's totally fine, it's totally fine. But the idea is Excel doesn't have, and I tried to squeeze this in up there, but it didn't work. It was too globby, and it was taking away from the answer I was actually asking, which is why I didn't put it in the footnotes. So, well this is good data to have though. This is good data to have, because now what I can do is I can make it more obvious where the footnote should be. Now the problem is though, part of the problem was critically thinking, should I find an average or not? If I only put how to find an average on ones that have an average, I've taken some of that critical thinking away.
Well,
but it's up to me to figure out how to make it clear.
What we did, because I did the same thing, when I read it for number 4 and I didn't have it, and so I knew to skip it, I read the footnote and went, oh, he kind of put that there as a hint, as in that would be crazy to do. Therefore, we probably should find one.
I would, just colloquially, and this is, you've known me only 8 weeks, so you wouldn't know this, I only make comments like that when they are truly insane. Like calculating degrees of freedom for a 2-sample t-test in 244. Like I actually put like a picture of a guy vomiting next to the formula. Because it's ridiculous. Like I would never tell you how to do it. I would say, Excel has the function, but it's not worth learning. And because it would take you longer. I wouldn't tell you how to do it and then be like, but you'll never do that. I mean, that's not fair. That wouldn't be fair for me as an education point of view. But you might not have known that, in the 3 weeks. So, but I will make this a little more clear, perhaps. Maybe what I can do, I got an idea. Refer to the Excel the footnote above or something like that. So instead of re-footnoting it, you might want to refer to the Excel footnote again or something along those lines. All right, average footnote. Thank you for that, guys. So essentially what you have to do in Excel is you have to do it by hand-ish. But you have to essentially create the third column, do the multiplication, do the adding, but okay. So thank you, apologies. Apologies.
That was my fault.
No, well, this is the way the course is made better, though. my hearing, that kind of stuff. Who knows? I've been using a similar project for this. I think it's right there, Scott. I've been using a similar project for years. I constantly tweak it and constantly add and subtract from it, but I mean, who knows how many students are confused with the same thing, so it's good to hear. I want to hear it. I want to hear it. All right. So, project okay? Two counting? F9 behaved itself for you guys?
Not on the Mac.
Not on, well,
Not on the Mac.
you know that.
I know.
It's not that anyone back.
Well, I had to get him to sit next to me with his computer because he was on the other side of the room. And I was like, no, I can't see it. So sit over here.
Yeah. But what I find amazing about that, and 244 just did the exact same thing. Whenever you can use Excel to simulate anything, it takes all of that work, because people often think of statistics classes. I talk to stat people all the time, taking stat class. It's the worst class I ever had, was a bunch of formulas memorized, and I keep thinking to myself, man, it does not have to be that way. I don't need to teach you a new formula for every one of those problems you guys did, minus the Texas Oral question. Every single one of those problems has a formula that you can apply to it to see if you can solve it that way. Every single one has that formula. But is it worth memorizing a formula just to have one problem approach? I don't think so. It's my opinion. I don't think so. I think if you can set it up as a simulation, it's better in two ways. Number one, it's not some weird formula that you really don't fully understand anyway, which you might understand later on, given enough time. But number two, you can actually see the data unfolding itself. Like the iPod Shuffle one. I love that one. Because you can actually see how hard it is to get 10 unique songs in 10 exact shapes. I thought about this the other day. I'm learning 2 songs to sing to a friend for her birthday, and I have them on shuffle in my iPod, going back and forth, and they keep going back and forth. The Cure, Katy Perry. The Cure, Katy Perry. I'm going to sing Katy Perry, it's going to be awesome. The Cure, Katy Perry. The Cure, Katy Perry. The Cure, Katy Perry. Back and forth, and I'm thinking, this is, what's that?
Is that going to be on video?
Probably, yeah. But you're missing the point! Said anything. Should have said Van Halen. But it just goes back and forth. The Cure, Katy Perry. The Cure, Katy Perry. The Cure, Katy Perry. It's done it for like 20 quick repetitions now. That shouldn't happen.
You need a bigger iPod.
No! I need a better randomized iPod. Bah! But that's the problem. Apple changed their randomizing algorithm because people complained about it about 10 years ago. We're testing that in 244. We'll do it Tuesday. We're supposed to do it today, but we're going to test it on Tuesday instead. That it's actually not as random as it should be because people were getting upset because they got too much Katy Perry and not enough of the Cure. Isn't that interesting? So they had to break mathematics to make people happy. Because, why? Because we suck at being random. But the only way to see the randomness is actually do something like that F9 on the Excel spreadsheet. So welcome to the future. I predicted in 15 years all classes are going to be taught like this. It's just me right now. Me and a few other people in Illinois that are all trading ideas back and forth. Anyway, blah blah. So, project was okay? You got one more. False positives, false negatives. False positives, false negatives never talked about in introspect textbooks. Should be talked about conversationally everywhere. Because this is how you can deal with that positive test result when you go to the doctor for your annual. And they tell you should be on thyroid medicine for the rest of your life. And you go, or we look back at every data point again, and maybe it's a false positive, which it ended up being. It's just so funny when I tested positive on this TSA. I think that's guys a story. The TSA. The TSA is so I get this right. There's 2 kinds of thyroid tests they do. Is that right? I think I got that part right. It's been about a year and a half now. Good Dawn. You correct me grammatically as I screw this up. When one level is elevated, the other is low. That's what I think I was told. I could be remembering this wrong. But when one number is spiked on these tests, it means your thyroid is actually underproducing. It's the reverse, right? It triggers the reverse. And a spike in this one number means hypothyroidism, which means your thyroid is not pumping enough. What does it pump out? What is thyroid? What is thyroid fire?
It's the TSH hormone.
It's just a hormone, right? It's not pumping the symptoms of hypothyroidism, as I was told by my doctor, are fatigue, weight gain, hair loss. Hair loss I didn't get.
Not you, basically.
Well, here's the funny thing. So he's looking at me. I'm describing how I have to ride my bike to Mount Bachelor and back twice to tire myself out sometimes to go to sleep at night. And he says, well, it looks from this test that you're hypothyroid. I'm like, okay. And I flashed right back to my son's second checkup when he was labeled obese because he was 80th percentile for weight and ignoring every other data point in the data set except for that. And I'm like, is there a possibility this is a false positive? Yeah. And that's when I realized he hadn't even thought of that. And then he was like, oh. Whew. Because the discussion right before that was about the lifetime of medicine I would then have to be on to regulate my thyroid. Number one, it wouldn't regulate it because it's not hypothyroidic. So whatever drugs they're going to be giving me might make it hyperthyroidic and put me through the roof even more than I already am. But the fact that the discussion of false positive, there was a number of tests. I was tested liver, I did a liver panel, heart, cholesterol, everything, red blood antibodies, everything was in this panel, and this one came back positive. Now in 244, you'll learn that 5% of the time you get false positives. 5% of the time you get false positives. It just happens. It happens randomly. So what I said was, can we take a time out and maybe retest me in 4 months, which I forgot to go back and do. But can we maybe take a time out and just think about this might not be hypothyroidism? And he's like, that sounds like a great idea. I'm like, whew, this makes me so happy that we have nurses in here. We have pre-nurse students. Yeah, just Natalie. Okay, Jenny, good. We got some, okay, Kate and Hattie, maybe. We got pre-med maybe in here? Maybe pre-med? Maybe not yet. It just makes me so happy that there is even one of you in this class, so that you can educate your colleagues later on in this. I love my doctor, but it disturbs me that he didn't even think of the possibility of a false positive. And it disturbs me even more that those stat textbooks have discussion of it in there. So that's your fourth project. Kate.
How often are false negatives?
It depends. False negatives are trickier than false positives, because false positives, what you can do is, okay, it's a loaded answer. And your project does a pretty good job of discussing it. From a statistical test point of view, a false positive is always 5%. This is not for a drug test or a disease test. This is when you're testing to see if a drug works. So you do a control group and an experimental group, and you give the kid. We just tested garlic today in 244. We got some data from an old British medical journal that tested whether garlic actually fights off colds. And they had tested 72 people and 74 people. 72 had gotten garlic supplements, 74 had not. And there was actually statistically significantly lower cold rates in the garlic group than the non-garlic group. Totally rad. And then all kinds of great theories came up, like, well, we're supposed to eat garlic and have bad breath, nobody talks to them so they don't get sick. It's just great. It was absolutely awesome just to explain why it happened. And I love it. At 8:15, they're coming up with clever stuff like that. But the chance of a false positive, which we got a positive test result, positively saying that we think garlic is knocking colds down, the chance of us being wrong is 5%. It could be there's absolutely no difference, but we think there is because we've got an outlier. The number 5% is tied back to our definition of outlier. 5% is unusual. If you land out in the tails, you're unusual. It might be unusual because of randomness, or it might be unusual because you actually belong in a different curve. That's what 244 is all about, the different curve theory.
It's like, as far as like the nursing thing, what you were just saying, like my
friend, go ahead.
She, thought she was pregnant, feeling just awful for weeks. And I'm sitting here, knowing her, I'm like, you're pregnant.
Yeah.
We take test after test after
positives,
test.
Positives.
Negative,
oh, negatives.
Negative for
oh, that's why you're asking about
weeks.
False negatives.
7 weeks negative,
Yeah.
we're going to the doctor, negative. And I'm just like, dude, I know you're pregnant. She's had been pregnant before.
I know you're pregnant.
I know you're pregnant.
I know you're pregnant. That's all.
She went in again, and then she was all like, guess what, you were right. And I was like, yeah, I know.
But the test came back negative. I've actually wanted the pregnancy test for years, but I can't get those numbers. So the statistical answer to your question is fairly simple. False negatives are still trickier than false positives, but they're doable. With those tests, the way those false positive and false negative rates happen on those tests is basically data collection. They have to go out and collect data. So your friend should report that to the manufacturer so they can add that to their data about false negatives.
Even she went to the doctors.
It's tougher than that though, because they're all based off of a hormone in your body, and everybody's body's different.
Absolutely, totally. But they still should have the data to refine the test. I'm not disagreeing. You're 100% correct. I'm not saying it's easy. None of this stuff is easy. But the fact that TSH can be a false positive, that doctor needs to know that's a false positive, so that they can go back to the test and be like, okay, are we getting too many false positives? Is false positive a bad thing, necessarily? See, here's the other thing, too. I was thinking about this the other day. My brain's always thinking about this false positive, false negative stuff because it's so important, which blows my mind that it's not discussed more in stat classes. So, the idea of when is a false positive worse than a false negative? Like, when is being wrong by saying something is there when it's not, worse than being wrong when saying something isn't there when it is. So for example, a cancer test, you'd want a higher false positive rate than false negative rate. That maybe, right? Because a falsely positive means you might go through, maybe not chemo, but maybe at least you get tested a second time, and the chance of 2 false positives is exponentially smaller. But a false negative rate, you get a negative test result, you walk away. Nobody questions false negatives. They question false positives. Right? Now, pregnancy notwithstanding. Yeah. But if you go and take a disease test and it comes back negative, nobody's going, whew, that could have been wrong, I better make sure I don't have this thing. Exactly. They go, holy crap, I tested negative, I'm out. Yeah. But if that's wrong, and then you carry cancer into the next stage, that's a bad thing. So arguably, a false positive for certain diseases would be better than a false negative, or a high false positive rate would be better than a high false negative rate, arguably. I'm not saying send them to chemo, they don't need it. But I'm saying, now spam email, another example, I think I mentioned this one to you before. Spam email, spam getting through versus spam not, versus legitimate email not getting through. Spam getting through is a false negative. Legitimate email being blocked is a false positive. Right? Think about why that is. If a legitimate email gets blocked, that means it was flagged as spam. It was positively identified as spam and sent to your junk folder. How many of you have been told, check your junk mail folders to make sure that, yeah, you've all been told this, that's check for a false positive. Nobody says check for false negatives because they're there. You see them. And I told you the story. I always do a little happy dance when I see one come through. Because it made it through all those crazy anti-spam devices. It made it through all those things that landed in my inbox. So I do a little happy dance and I delete it. But again, false positive and false negative aren't always the same rate, and sometimes some are more important than others. That's what your project gets into. So, one last 10-page tome of Sean to read through. This one has a YouTube video accompanying it too. I did manage to get one of those on there for you. So, and I think the way I come at it is pretty straightforward. There's a way to use it using a formula. Yeah. So there's a formula, and this is one of those things. There's the formula for it. But you're not going to use that. You're going to make up, you can also use tree diagrams, which are fun. But you're going to use t-tables, contingency tables like this. You're going to analyze tests 4 different ways. There's 4 ways. If you take a drug test or disease test, 4 things can happen. You can test positive or test negative. But you can test positive correctly or wrongly, and test negative correctly or wrongly. And that's what this t-table idea has you analyze over and over and over again. And it has, basically what you want to do is you want to minimize these and maximize these. I mean, clearly, that's what you want to have happen. You want to be wrong as little as possible. But we don't have control over that, as we can see from the pregnancy tests. So, enjoy. Have at it. Have at it. There's no Excel component to this one, I apologize. It was actually more direct, not using Excel simulations, just using percentages. So, you could make it in Excel if you wanted to. Yeah? Yeah. How's week 8? How's week 8? Is that alright? Is this? Sorry. Yeah. Oh, you're not responding. Yeah, I know. So, week 8's okay? We're getting there? We're getting there. We're going to start coming into like the coasting of 243, which is nice. We're getting to the point where we can. Anything from Binomial give you guys grief? We're getting close to the end here. Anything in here give you guys any grief as far as please, Robert, go.
Yeah, 41515. I punched that in my calculator, but
yes.
I kept getting an error.
Let's figure out what it is, huh? Let's figure out what it is. 41515.
If I changed it to a percentage, it worked.
That's interesting. Hang on one second. Let me follow this up. And that's on page 186. It starts. So that would be 196, if I remember correctly. Oh, 196. All right, 41515, you said?
Yeah.
There he is, right there. According to the South Carolina Department of Mental Health website, yes? For every 200 U.S. women, the average number who suffer from anorexia is 1. So 1 in 200. There we go, 1 in 200. There's your probability that we need.
Right.
We need that, 1 in 200. Out of a randomly chosen group of 600 U.S. women, how many are expected to suffer? Find a chance that no one suffers. Find a chance that more than 4 suffer. Okay, so let's grab the TI and use our dist fill. Is it binomial? Definitely. Because?
They gotta either do or
Right, they either do or don't suffer from it. Do we have independent sampling?
Yes.
I think it's arguable, yes, Dawn? We're picking 600 women. We're picking 600 women out of, what's the population? U.S. women. Well, that's, you're not picking a large enough chunk to worry about it not being binomial anymore. So it's arguably independent. Consistent probability of 1 in 200. There you go, right there. We can actually answer the first question without using the TI, and it needs, hang on a second, there's a part A, B, and C too.
Right.
And I forget what that is. Define the random variable, list the values x may take, I'll give the distribution. So we can actually do most of this all at once. What variable are we interested in?
Number of women that suffer from anorexia.
Number of women out of that sample of 600 that suffer from anorexia. So that's the part A. We often do that verbally in class. We'll often go, what are we interested in? Are we interested in winning the game, losing the game, number of pips? What are we interested in? That's what the random variable X is going to be. As far as B and C and D, I think we get all that from the distribution itself. So let's come back now and make sure I got the numbers right. All right, so let's fire it up. Oh, you're good, you're good. Look delicious. All right, smallest X is 0, largest X is 600. Give it some time. It's gonna have to fill up this list with. Ooh.
Mine gave me an error.
Oh, shiza. It might error out. I never thought about this. That might be too
No,
big
mine
for the
worked.
TI. Yours worked?
Mine worked.
Yours worked too, Stacy.
But you errored out, Michael.
Yeah. I'll try it again. Maybe.
Try it again. This is weird. I thought 600 might be too big,
No,
but I guess it's not too.
mine worked.
Yeah, mine did too.
Right now it's filling it in.
I'm gonna do something real quick. I'm gonna stop it real quick, and I'm gonna go quit. I'm gonna go back and look. There's L1. I'm gonna do a bastard move here real quick.
Yeah, mine errors.
Yeah, okay. Yours is arrowing out, and it's who else is arrowing out at this point?
Oh, I went to go do the 1 and 200, and then it gave me an error.
Then it gave you. Okay, hang on. Let me. This might be something I have to create an Excel spreadsheet for, Robert, to link into the homework. I didn't even think about this. This might fart the TIs out.
They had like an answer for free.
We can actually get these. We can get. We can get this answer pretty quickly without using the TI at all. Just use an old project, and we can technically get that one too. But I would never ask you to do it manually. I wouldn't ask you to do it manually. Let me just do this again real quick. I just want to see if mine errors out as well. So, has anybody gotten through the distribution?
Mine's still thinking.
It's still thinking. This is ridiculous. I shouldn't have this. I'm going to make an Excel spreadsheet for this. This didn't even register when I was putting the book together. That it would kind of fart out here. So I'll tell you, Robert, go
What's
ahead.
your probability then? It's like 1 divided by 200.
1 divided by 200 is going to be your probability, yeah. But it sounds like we're getting errors. 1 divided by 200. What's that? That's 0.005. So mine's thinking. I'll tell you what. Let it think. I think I'm going to error out. I'm almost positive it's going to error
That's what
out.
mine did.
What I will do, and I apologize, thank you, Robert, for asking this. What I will do is I'll make an Excel spreadsheet to accompany this problem. So essentially, we'll do a super dist fill in Excel. So you'll create, kind of like you did in your take-home you just did, and you'll actually drag the formula down for, you'll be doing what this program is doing in Excel, which I think is probably a better tool anyway. It worked?
Yeah.
It might still going. But the fact that we're getting so much inconsistency, I'd rather have an Excel-based solution that we can actually all do. So let me grab a pen real quick and write myself a note. This is 4:15:15, yeah? And I'll make a video to go along with it, that way it's not confusing. Solution. Thank you for asking. Now, mine's still thinking, we'll come back to it. We can actually answer D and E without the program though, without the distribution. So it says, how many are expected to suffer from anorexia? When they're asking for expected, I put a little footnote on the homework sheet. What does that mean?
Percentage times sample.
Good, because what am I asking? I'm asking for how many of the 600 are expected. There's also two, I can put a comma and 2 more words. Oh, it's done? Okay, so I'll make the Excel sheet, I promise. What am I asking? How many of the 600 we expect to get anorexia, comma, on average? That's what expected me. I made a note of that up in the homework sheet itself. I'm just asking for the average. Now, we figured out a quick shortcut for the average in class for the binomial. The shortcut for the average in class for the binomial is you just take the number of trials, which is 600, times the probability of success in the trial, which is 1 in 200. So you'd expect 3 women of the 600 to have anorexia. You'd expect that, if that makes sense. Now, let's see if I can do this. Like I said, I want to make an Excel to fix this, but since it already works up here, L1, L2, let's see if it, this might take a long time too, I don't know. Oh, there it is. There it is, X equals 3. So I'll have you do this via Excel and you'll get the exact same result, of course. But that's your result. You can see though, it's actually taxing the TI too. That should also be 3, but that's not coming up as 3. And look, that should be 1. And it's making it work so hard in that list that it's missing some of the accuracy of it. So this is a perfect example of when we need to bypass this and go to something else. So, that's that. Now you can also go into my list and take a look now, and you'll be able to do this once we get the Excel sheet up and running. There's your probabilities. Remember how we said on average we should see three of them getting anorexia out of the crew? Well here, 3 is the highest probability. I mean, it's close to 2, it's getting close to 2, but the lion's share of the probabilities exist right here, between 0 and like 5 and 6. As soon as you get past that, they start dropping off, and then they start dropping off precipitously. Because if you have 1 in 200 women that you're expecting to have anorexia, and you end up with 20 out of 600, it's not really 1 in 20 anymore. Now it's or 1 in 200 anymore. It's more like 1 in 100 or 1 in 50, which is a higher percentage than what's being claimed. Is that fair? Yeah, good. So that's, you can do binomial averages without having to use the TI, but I didn't expect you to. I expected you to use the TI, I expected you to use an alternative. Anyway, here's a question. Find a chance that nobody suffers from anorexia. Now the TI gave that to us. He gave it to us back up here. No one suffering, about 5%. Could we get that without using a TI based on your, not your project you just did, but the project before that? I want to make sure this is pointing in the right place so you can see what we're about to do. It's ish the right place. We'll go over here. What's the chance of anorexia, friends?
It's 1 in 200. So is it like the chicks?
It is exactly the chicks.
Like the chicks?
It's a chicken and a rooster. It's a chicken and a rooster, anorexia, not anorexia. It's a two-sided coin. But you have to look at the weights. The chance of anorexia is 1 in 200. What's the chance of not?
199.
Yep. It's 199 out of 200. Exactly. So that's what you kind of have to keep track of, is keep track of the 2 parts of the binomial. Now the TI does it, and Excel will do it for you automatically because it's doing that balance as you're working through. So now what it asks is, if you ask 600 US women, what's the chance that none of them have anorexia issues? Well, that's the chance that 1 of them doesn't. What's the chance that 2 of them don't? Say it, be brave. Wouldn't it be that squared? Max going into the box. Grabbing a rooster. Another rooster. We squared it, right? 3 women. 4 women. 600 women.
600.
To the 600th power. So the chance of 600 women all not having anorexia. Whoever said, isn't this just the chicken? Thank you for saying that, because that's exactly what it is. It's just the chicken problem. Every binomial problem is a chicken problem. Every single one. It's either a rooster or it's a hen. Everything. Rooster or it's a hen. You just have to pick which one's which and keep track of it. If we're saying none of them have anorexia, that means we got a chicken 600 times. Now your TI will do this, obviously, or Excel will do it in this case. But all we've got to do is do that 199 to the 200th power. 600. There you go. Does that number look familiar? Does that number look familiar? 0.049413. It should.
Yeah.
Because it's that guy right there. It's that guy right there. That's it. Now, and this is why in your second project, I had you doing the alls and the nones, but I was staying away from these middle probabilities in the distributions. I wasn't making you do what's the chance that half of them or 2/3 of them, because that's where machinery comes in handy. Just keeping track, as you saw with the chicken flock, keeping track of all that gets a little challenging. It does. It does. So that's why we were kind of ignoring that for that period of time. And that's why we won't answer F until I get the Excel spreadsheet up for you. Because in this one, what's the chance that more than 4 suffer? If you have the distribution in front of you, it's actually a piece of cake. More than 4 means what?
Well, like
Everything
everything over 4.
Whatever they were 4. So 5, 6, 7, 8, 9,
596.
down to 600.
So it'll be
So,
500.
exactly. So one of the things you have to do is add up all these probabilities all the way down. Or, as Michael just said, a much easier way to do it is to figure out what this is and subtract it from 1. Which using the old trick from your project as well. But none of that can be done unless you have that distribution in front of you. That's the challenge.
Can you use that there for that?
You don't want to, because here's the problem. Yes, you can. The answer is covered, yes, you can. But the problem with this is you'd have to say, okay, we have one of them right now. There's that. To figure this one out, we'd have to figure out how many ways can you have one woman having anorexia and 199 not. So then you have to start getting into that, what number do you multiply by? Remember that? Hattie started shaking. You still remember that? Remember that? The 14641
Right.
and the 1331 and then the 15101051. Imagine how many of those numbers there are here.
So there's a coefficient involved.
There's a and that's exactly why I gave you this gift of this program,
Okay.
because that takes care of the coefficients. Now, I am going to throw a quiz up for you guys for next week. I'm going to put a couple quizzes up. I'll make a binomial quiz, and I'll also make if you want to explore the binomial, I have a quiz on those coefficients. Because some of you seem like you were like, that's kind of cool, like 1, 1, 1, 1, 2, 1, 1, 3, 3. You were kind of like into what the patterns of the numbers were. So I made a quiz up about that. So if you want to do that one too, I'll have that one available for you as well. But I'm never going to ask you that in this class. I want you to be able to pull those numbers off of here. The thing that blows my mind is this. There's only a 5% chance that none of them have anorexia. So what's interesting about this is the kind of thing you can use to raise points of discussion. So anorexia is one of those diseases that doesn't get talked about a whole lot. For whatever reason, societal reasons, whatever reason. But this is the kind of thing you can say, do you realize that out of a chunk of women this big, there's almost no chance that none of them are anorexic? Which means by the double negative property, there's a good chance that some of them are. You see what I'm saying? You can raise awareness to something because you look at this and, oh, anorexia, that never happens, it's 1 in 200. Yes, it's only 1 in 200, but then apply that out into the population. Say a population of 600, and all of a sudden there's almost no chance that none of them have it. And this is going to keep going down as that keeps getting bigger. You see what we're getting at here? As that gets larger, this is exponentially going to drop. If that goes to 1,000, that goes below 5%, even further. That goes to 2,000, that goes even, apply it to our COCC campus. Apply it to our COCC campus. This disease rubs me in a very emotional way because I've known lots of people that have had it. So, but it's one of those, it doesn't get talked about that much. You don't hear it that much. It's one of those silent ones, right? But this is the kind of data that actually allows you to come forth and say, hey, look, this is a very small chance. If this was like 95%, the chance of nobody having it is 95%, then I'd say maybe we don't have an issue. But it's not 95%, it's the opposite of that, it's 5%. That's when I sit back and I say, maybe we should be bringing this to the discussion table more. That's the power of this kind of mathematics. It allows you, it gives you ammo to discuss. Now, the downside of that is the person you're discussing with has to understand what the hell you're talking about. I learned on Tuesday at a meeting I went to that that's not always the case. But it's 1/10 of 1%. Yes. Okay, so you obviously don't feel as strongly about that as I do. And that's the thing, like, you can throw numbers out, throw figures out, and throw understanding of it out. But unless the person that is holding the purse strings or holding the change, if you will, the change catalyst, can understand what you're talking about and believe you, it might not happen. But getting there is half the battle, making sure you understand. And that's why that depresses me a little bit. The fact that in 600 people, there's that small of a chance that none of them are affected, which means there's a 95% chance at least somebody is. So heads up, I didn't even depress anybody. I think I just depressed the entire class.
Calculator gave up, you depressed it.
I depressed it. That was good. That was good. That was good. That's a Sean quality joke. I.e. very, very bad. Very good kid. I loved it. I loved it. Anything else in there? Give you. I apologize for that. I'll fix that problem. I promise I'll fix that problem. Skylar, go.
Number 9, part F. I kept getting a different answer.
Well, let's find out what 9F is all about. That's up here. School newspaper, this one here. We're going to survey 12 students. You think the guy can handle this one? You see if they will attend TET festivities this year. She knows that 18% of students will attend TET festivities. We are interested in the number of students within the festivities. Okay, so first of all, I didn't bother making a video for this because the solution's on 207. Can anybody see a reason as to why one of the possible solutions to this would be putting your hands up and saying, I refuse to answer this question? Can anybody see why you refuse to answer this? The problem with this one is, we're surveying 12 students. It says 18% of students attend TET festivities, but nowhere in there does it tell me how big the school is they're drawing them from. Is this a large school with thousands of students? Or is this a very small school like we have in Bend? And I never really thought about this until I moved out west. The schools on the East Coast are huge. You got kids packed into the top of their heads. Out here, you've got schools like the first school that offered me a job was Cascades Academy. I would be the only math teacher for the entire school. I was like, what the hell are you talking about? They're like, we have 25 students. For 12 grades? Like, yeah.
What?
I'm like, that's like 2.3 children per class. They're like, yes. I'm like, okay. That's interesting. And then I walked away and came up here. But the point is that that 12 is a little misleading because you might have a very small draw from that. So let's make the assumption, shall we, that the school is large enough so that drawing 12 from it doesn't change percentages all that much. Is that fair? Okay, good. All right, let's do it. Let's do it. Back to program, binomial. Erase the board too. All right, smallest? Largest? Because we're asking 12, so that all 12 could say yes. And we're going with binomial because they either do or don't attend the festivities. All right, the chance, 18%.
I mean, 1 divided by 12 is close to 18, but it's actually...
It's 8.
Oh, no, that's like the wrong number. Yeah.
That's okay, that's okay. 8 and 8, I think, is my math right. Cool so far? Let it think a couple seconds. Boom! Done. Let's go look. Edit. So here we have number of students out of the 12 that are going to say yes, we're going. Here we have the chances of those. Here we have a column you don't need because that's carried over from 244. Clear that out of there. All right, so what's the most likely answer? 2. What's the average number of kids? Boom! Couple different options. One of our stats. Or just do 12 times 18%. Either one gets you the same answer. So roughly 1/5 of 12, somewhere just over 2. So average is linking up pretty nicely with this. If you want another look at it, by all means you can draw it. Here's the distribution. Again, looking like a bell curve with a long tail and a missing tail over here. We'll come back to that today. Okay. So here we are, 2, here's 1, here's 0, here's 3, here's 4, and so forth. So you pretty much aren't going to see this happen over here. That's the indication of that. That's not going to happen. This is going to happen.
I say just wrote it down.
Oh, it's all good. We can look at F though. It's totally fine. So Skylar's question is, what's the chance that more than 2 students will attend? Let's just answer the question. We're here. More than 2 students will attend. Okay. Well, what is more than 2?
3 and over.
3 and over. So what you need to have is you need to have all these probabilities all the way down until you got the 12 over here, and add all those up. Or be slicker about it and add these 3 up and subtract it from 100%, which I think is the way we should do it. So that's about 9, that's about 33, that's going to be 52, is it 48%? Somewhere in there?
Yes.
What do you guys get? Because I'm adding this up really quickly in my head, which is always suspect. Oh God, I had it wrong. That's 30, 54, 63, 37?
37.
There we go. There we go. I forgot to carry a 1.
Let's do it at most 2.
Oh, at most 2! Well, actually, that's exactly the compliment. At most 2, Skylar did at most 2 instead of more than 2. Well, at most 2 would be this. Which is exactly the complement of what you need. You actually have to do that to get what you actually would need, right?
Yeah.
At most is the opposite of more. This is where the English language, exactly, this is where the English language gets annoying. Because then you can say more than 2 is related to at least 2, which doesn't make any sense. Because the word least is tied to the word less, which makes you think down. But when you say at least, it means start here and go higher. So more than 2 and at least 2 I'd have to start it here. That's where English gets in the way. But as long as we understand what's being asked here. Michael, you had a question or a comment. What was it? Go ahead. I thought you did. Maybe you did. Oh, I thought I saw your hand go up. I'm sorry. Solid? Good? Okay, good. That's good to do anyway. Why not? Why not? So I got a binomial quiz for you for next week. I didn't post it. I'll post it when I get back to the office. It's a fun one. I read it in Rolling Stone a while ago. The political poll of Rolling Stone, always a good time. And the other one, I'll put up a second quiz if you want with the coefficients. Because there are coefficients in here too. The 12th row of Pascal's triangle would exist in here. So it'd start with 1, 12, and then go to something else. I can't do it in my head. So pretty fun stuff. But you got that glaze. Let's take 5, yes?
I knew you were going to say that.
You got the one you can type
I
it
was kind
around.
of like, it's 11 o'clock, he's going to say.
Well, because you get the glaze in 45 minutes. It's almost like a clockwork. It really is. 45 minutes, let's take 5. I love it.